And so, welcome everybody to week number 3 of the Intermediate Data Science Workshop. I'm going to have Dr. Montani start off, and he's going to discuss the Google Colab. Go ahead, Aaron.
Yeah. Hi, everyone. Thank you for having me, Dr. Hoyt. Happy to be here to briefly talk about Python notebooks in general. There are a bunch of them that are currently available. Jupyter was, I think before Colab came in, was probably the most widely used, and then Microsoft has created a Visual Studio Code as well. I personally liked working with Colab because of how easy it is to use and also how easy it is to share with different individuals who are working on the same project. So essentially, what is a Python notebook? So these are documents that that can combine code, text, equations, and visualizations, and basically you can you can start your machine learning project here with lines of code. When I had done my data science courses, we would have to kind of know how to code, but what's happening right now is all these or most of these notebooks are linked with their large language models. For example, Google Colab has Gemini, Microsoft has Copilot, and then that helps you, refine your code and make it easier to code, so to speak. So the way it works is essentially if you type a prompt in the Google Colab notebook, which I'll show you a little later, it'll spit out code for you essentially. So we'll go over that in a little bit. So starting off with Colab. So the website is colab.research.google.com. Essentially, it's short form for collaboratory. And what it means is, or what it helps is, you can you can start coding in this notebook on a web browser itself. You do not need any extra software. You do not need any extra RAM or GPUs to kind of run your code because all of this is done through a cloud-based system. And you can run the most complex machine learning models or algorithms using their online GPUs or TPUs, which we'll talk about. So so starting off, each Colab notebook, like I just opened a new one. So this is essentially called as a cell, and that's where you type in your code. So here it says you can start coding or generate with AI. So that means now, let's say, so here in this example, they're looking at seconds in the day. That's the variable, and this is the calculation. So so like this is not advisable, obviously, like to copy paste your code, but I'm just showing you a brief example. So essentially what you would do is you would type this in into the code cell and then plays when you're executing the code cell. And here you would see that on the top right, it says it's connecting. So essentially what's happening is it's connecting to the online server of Google and sort of using their CPUs and GPUs. One thing that is really useful is if you feel like the program or the machine learning model that you're creating is going to take a lot of RAM, you can always change your runtime type. So since we're using Python, so this is Python 3, but you have something called as hardware accelerators. Basically, what they mean is they are able to increase the your RAM usage, or they are able to expand the memory that you want to use in Colab. Some of them is free, some of them you will have to pay. Like for example, the A100 GPU or any of these that are blacked out, you would have to pay a price for it. But otherwise, you do have some pretty powerful ones that are for free, the T4 GPU and the V28 TPU. I think I've probably used the T4 GPU once or twice, but most of my programming has been done on CPU, and that's worked pretty fine. Um, so that's essentially how it works. So here we typed in seconds in a day, and then we did this simple calculation. So if you wanna, you can either, press enter to generate another line of code. So you press shift and enter. On the Mac, it's going to be shift and return. And then if you just type seconds underscore in a day, so it pops up by itself now, which it never used to happen before. And if you create enter, or if you type shift and enter, you get the answer to what your variable you have stored it as, which is essentially the calculation that was described above. So so that's the simplest or the easiest way of coding. Now with Python, you do have libraries. Essentially, libraries are sort of like you can think of like widgets on an iPhone, which kind of are add-ons to the main Python notebook or the main Python program, and they help perform different tasks. So, for example, NumPy, or as popularly it's called as NP, basically what it does is it helps with calculations, and Matplotlib is another library or dependency that helps with creating figures or visualization. So, so in this like sample line of code, what is happening is we are installing NumPy. Sometimes, there are packages that are already installed, but if you want to install a package, you can say pip install, say NumPy, and then you hit enter. Essentially, it's gonna So when it says requirement already satisfied, this package has already been installed on this notebook. So there are certain packages that are already installed on Google Colab. NumPy and Matplotlib is one of them. So once you install the package, next you would have to import the package. So the next step would be importing NumPy as NP. And essentially, NP is going to be used in your subsequent line of code. And that shows that, and that's just indicating to Python that NP is being used, or the package NP needs to be used in that specific line of code. So here, essentially what we're doing is you're creating, random numbers, and then you're kind of plotting a figure in the x-axis and the y-axis. So what's happening here is, PLT is Matplotlib. So you kind of do the same thing where you pip install Matplotlib, and then you import Matplotlib as PLT. So if you have so the way I kind of do it is, on one single cell, I kind of install all of the packages that are required. And then on the next cell, I import all the packages. So it's important to have, a clean Python notebook, because if you're sharing it with individuals, it needs to be understandable. It's almost like, you're writing text, and, it's important that the text is understandable to individuals that you're sharing with. Another important feature to improve like efficiency and understandability of your code is you can create some like hashtags, and essentially when you're executing the code, it's not going to execute the hashtag. So you can type, for example, if I press enter here, and I can type um, numpy package inst installation. So here, essentially, what's happening is whatever's in green at this point, the code cell is not going to recognize that it needs to be executed. And then only thing that it's going to execute is the pip. So, and for example, like if you're testing code, or if you're writing code and you want to keep that code in the cell, but you don't want to delete it. You just want to try something out. So the alternative way is, instead of like deleting all of this, copy pasting it into a different, cell or something like that, all you can do is you can just hit hashtag. So this is going to turn it green, and the when you try to execute a code cell, it's not going to get executed because it has the hashtag in front. So let's see. So essentially, like, this code is, you're creating uh, uh, a graph. So we spoke about different GPUs and TPUs. Basically, it all depends on how much memory you need to run or execute your code. So there are a lot of resources that are available, offered by Google Colab, and Google in general, to help you learn or improve your coding. This is a website that they do have a lot of courses that are available, um, to, to go over, like, machine learning, to go over coding, and kind of gives you a crash course. So I think it's important to take a look at this. We did go over a lot of this in our basic, courses, and also going over this in the intermediate courses. But just for self-learning or understanding, this would be a good resource to have.
Aaron, would you comment on the fact that this sort of environment has changed because of the fact that large language models can generate the code, they can debug the code. So, in other words, you can, and I'll demonstrate this later,
Mhm.
you can go completely without code, analyzing data, or with code, or both, and that this gives you the ability to copy paste almost every one of the large language models, allows you to copy the code and paste it into a notebook. So
Yeah.
it's kind of different than it was, say, 2 or 3 years ago.
Yeah. So as I was saying, like, this was back in 2020, 2021. Like, essentially all you would have is, these code cells, and you would have to figure out what's the right code. But now what you have here is another taskbar, or another bar, which says that, it's linked to Gemini, which is Google's large language model. And you can kind of, improve your code. You can, if you're stuck on something and that you're not aware of how to code, you can kind of put it in Gemini, and they can show it to you. So for example, if you're saying, in this case, 10 random numbers using NumPy, let's see what it shows up. So essentially, what it's doing is it's giving you the code. So instead of you kind of typing it, installing it manually, it's kind of creating this code cell, and it's giving you, you know, the exact code that you need. So if you are executing this, oh, so that's essentially what you get. So that's how easy it's become to code, even easier, since the advent of large language models. So, now it seems like you should not be going wrong with any of your code there. But obviously, like, these are very simple tasks, and there are a lot of data analysts and data engineers out there who do, like, crazy coding. Um, so let's go over something called as Markdown. So Markdown, essentially, it's these are text cells, and are formatted using a simple markup language, which is called as Markdown. If any of you have used R, you do have something called as R Markdown. So it's kind of a similar thing compared to R. So essentially, when you type um, hashtag section 1, section 2 in these code cells, what what you get is essentially this as your output. So instead of typing code, you're essentially typing text, and you're getting text out. And then, these are the levels of indentation that you can use. So it's all represented by the arrowhead. So one arrowhead is one level of indentation, and two arrowheads is two level of indentation. So this becomes important when you're having like a lot of lines of code. And if you feel like you want to make it look presentable, or if you're kind of presenting it as a PowerPoint, you can kind of use this format as well instead of the hashtag format that we went over. So that is another way of kind of, arranging your notebook so that it looks presentable.
And
Um,
Aaron, I don't know, I was multitasking whether you commented on the hashtag, uh, the significance of that. For instance, here, if you put a hashtag, NumPy package installation, it
mhm,
doesn't count as code.
correct.
It's just a reminder, if you will, of what's going on. So that
Exactly.
hashtag is not part of the code, in other words.
Yeah, exactly. So now let's say if I'm going to run this cell, essentially like there is no output because there is no code, because this is zero or this is null for the code cell. But if I remove the hashtag and I run it again, so it should say requirement satisfied, which is doing because it's recognizing this as your line of code. And this is essentially like a reminder, or almost like a synonymous to like a sticky note, to say that this is what this code cell is actually doing.
Are you going to import any data to show them how to do that, by the way? Over
Uh,
on the left, with the folder.
I can show that. I don't have any data per se, but I should be. Okay, so there is some data here which is sample. So all you could do is, um, you can click on the data. And then essentially all you have to do is, double click on the data and it kind of pulls it up, and it gives you an idea of, what the data looks like. You can kind of change the number of entries that you want it to display. You can kind of, you know, adjust the width, and and yeah, that's pretty much it. Is there anything else I missed?
Uh, well, I think one thing might be that you could show them a simple thing about reading in that data set, let's say California housing train,
Mhm.
read it in, and then show them the importance of the path. They have to copy the path into it.
Okay, so essentially like the read.csv.
Yeah.
Okay, all right. So when you want to import it into Google Colab, you can do it in two ways. So one way is um, you can import from Google Colab directly, or you can sort of mount your Google Drive onto Google Colab. So let me see if I can put it in in So the other thing is I also use Stack Overflow. Like, so whenever you're like stuck on code, um, so you can use Stack Overflow, and it does give you like answers. So you're going to be using this function, which is called Colab. So, and then what it's going to do is it's going to connect to your Google Drive, and then you put in your password, and you know allow this whole, don't allow this. So the reason why it's giving me an error is because I didn't click on the options to allow everything. So let's just do
I
that.
guess what I was thinking, and I want to make 2 points. One, the only disadvantage to Google Colab that I'm aware of is that the data does not persist. In
Hmm.
other words, if you upload your favorite data set to analyze, within what, a couple of hours, it's gone.
Right.
So, that's one thing you have to be aware of. But as you cut and paste code in there, you have to, let's say related to a data set, let's say somewhere else you ran, you requested the code, a large language model create the code,
Hmm.
you paste it in here, you need to still have the data set uploaded on the left. And
Right.
then you need to be able, and that's what I wanted to show them, how you set the path so it
Oh,
knows where to find it, to read the
so
CSV, in other words.
right. So tab. So I'm gonna close this.
Well, we can later cut and paste code in there if you want to. Maybe that's a better way to do it.
Yeah, but so we have imported um so let me just import pandas here. So I'm just gonna create another line of code, import pandas SVG, and then do that.
Pandas is a kind of a workhorse, by the way. It's how
Mhm.
you get the basic descriptive statistics and you look initially at the data and whatnot. So
Right.
almost always pandas is a package you would import.
Yeah. And then so if I want to import this data set onto the notebook, so what I would click on these three dots, I would copy path. And then essentially what you would do is you would paste it into this line of code and hit play. So essentially you're getting, you know, whatever we saw here, you're getting the same thing, in your notebook too at this point.
Yeah,
So
that
you,
that was the point I wanted to make, is that's what you need to do. In other words, to read that in, that
Mhm.
CSV, to
Yeah,
get started, if you will, then you can go on to do a bunch of other stuff.
correct. Then you can, we went over, you can change the names, you can, change the decimal places, you can figure out if there is like null values and stuff like that. And you also have uh, different ways of viewing it. You can view it as a table like this, or and then you can also, now this is giving you distributions just by one click. So instead of you having to type the code, you can kind of get what the distribution looks like for
Yeah.
each variable. So that's
Go back up, because that's one I have not used, to show that icon that you just,
it. It was this one.
okay,
It says it's called suggest charts.
okay.
Yeah. So it gives you automatic. So and then if you click on it, it's going to basically give you the code that was used to generate that plot. And then you can basically just um, add cell. And then if you wanted to make it bigger, you just do that and you click on it and then you get like a bigger version of it. So,
And to download it,
and to download it, let me see. You can also say download notebook to computer. So essentially, you would use
and
this and then files to download. So I've named, so IPY and B is your interactive Python notebook. Um, it's currently untitled 14, so you could just use this and then back here, and then let's see.
but you want to go up to the file menu and show them where you save it, because what's nice is it's saved to your Google Drive. So
Mhm.
let's say today you played around with a data set and did everything you wanted and you wanted to preserve it, you would go up there to file.
And then you could just save it here. You can save a copy in the drive. You
Right.
can, save it, or you can even download it as a IPYNB. So,
Yeah. So you can attach that to an email. In other words, if you did something in Python, you can share it. And
yeah,
plus there's a share button in the upper right as well.
yeah, it's right here. So you can share your notebook. You can add, or, you can share it with whoever you feel is part of the project, and then that's pretty much it.
So one other comment, Aaron, is
Mhm.
that if they use, say, the standard, say, GPT-4 or O1,
Mhm.
it's not going to produce visualizations. So
Yeah,
that is why you would take that code, and almost everyone has a copy code button.
right,
You'd come over here, you'd hit the positive code. You want to
correct.
click that just so they understand.
Yep,
And then that's where you'd paste it in.
right,
And and that then it would generate a visualization below it.
correct. And so it'll come as an output. So it'll be something similar to this where you paste your code in the next you would paste it somewhere here, and then essentially what you would get is this output or this visualization.
And just one more thing is how about hit plus text just so they see what that so they understand that. So there's where your markdown language is. There's where you
Correct.
can say we just did whatever.
Yeah,
Uh, and that's how it works. So that's how so you could have your code and the output, but you could have a description of exactly what you did. And
yeah,
people have done coding textbooks using this kind of approach.
yeah. So for example, if I want to say I want to create a text here and say California housing, and it gives you a preview as well. Um, and then you just click enter. So then it gives you, um, the way to, so this is like your heading essentially. So, like what's coming next. So you can structure it and you can make it look, nice and organized based on your liking. So there are a lot of different ways of playing with Google Colab, and it's, with the integration of Gemini, it's so easy to generate code. So, that's what makes it a lot of fun to, like, if you have any idea, or if you have a data set and you're thinking of analyzing it, or you have a project that you want to create some machine learning models or predictive models, like all you have to do is upload the data set, and then you can always you can just integrate Gemini and then start asking questions on how to, like, create models, or or analyzing the data set and stuff like that. So it makes it a lot more easier and seamless than initially when I first used it.
Boy, you're right. And also there are Python packages still being released out there.
Mhm.
There was two. One was a networking package, and another one was a brand new algorithm called Tab PFN,
Mhm.
which outperforms most algorithms, by the way. It's used as a transformer. It's totally different. Well,
Yeah,
the point is, I had no idea how to use it. So I said to whatever the large language model, I want you to install it. I want you to set up a classification model. I did it all with natural language. I didn't write one line of code. It did
nice.
everything
Yeah,
for me. So when you see there's a new Python package, you actually don't necessarily have to write code.
right. So, large language models have made it a lot easier in terms of coding. Um, I still do it the very, like, ancient and old way, where I go to Stack Overflow, and if I've forgotten some code, I look over it. But obviously, like, there's much more simpler ways of doing it at this time. I think
All right,
Faisal.
so you had a question?
Yeah, this has blown my mind. You know, to be able to code with natural language, you make it look so easy. And just 2 days ago, I actually paid my subscription for Google Gemini, and I think Google Colab is part of the Google Gemini prescription.
Yeah.
So I'm looking forward to dabbling with it. Um, last time I coded anything was when I was in school using BBC Basic. I want to see if you have any tips, like top 3 or 4 tips for making this work smoothly with natural language. Like, is there? I'm sure it's not quite as natural as you would
Well,
talk.
we're going to show you just that in a second, whenever Aaron feels. In other words, when we wrap up Colab, we're going to go to Vizly, which is going to be natural language, doing data analytics. And we'll also show you Gemini embedded with Google Sheets. So we'll show you 2 ways that you can go totally natural language and avoid code if you want to. Okay.
Awesome.
So,
Thank you.
all
Yeah.
right. Are there other questions about Colab? Because that's what we recommend if you're going to play with code, in any way, shape, or form. Colab is just easier. Uh, Jupyter Notebook you need to download from Anaconda. There are some other steps and whatnot. There is a Jupyter AI, by the way, but it's pretty buggy. I can't, it sounds good, but it's not as good as some of the other things we'll show you.
Right. Yeah, I think that's pretty much it. That's like the overview of Colab. If you guys have any questions, happy to answer them.
Yeah, well, that's great. Thanks for steering the
Yeah,
presentation there. Let's see.
I'm
It
gonna
says
stop
allow.
sharing. Yeah.
Now, can you see my desktop? Let's see.
Yep.
Okay. So let's go straight to Vizly. Now, let me say up front that this is the program that I use the most. I've tried Julius, I've tried all of them. There's Power Drill, you name it. This is one I've found to be most reliable and least buggy. You do have the choice of Python and R. And let me sit what connected. I think I hit the refresh button, it'll be reconnected. There we go. So you have a choice of several large language models, and I suspect they'll add some, but the default is GPT 4.0, which seems to work well. So what I wanted to go over is a couple of things. Now, this is a data set that from the World Health Organization of the death rates for 60 years for every country, 1960 to 2020. And what I wanted to first point out is this is longitudinal data. Have you ever tried to reconfigure an Excel spreadsheet to make sense out of longitudinal data? It's not very easy. You'd spend a lot of time doing that, in other words. So instead, you can just simply write what country has the highest death rate in 2020. That's all you have to write. So below that, there's that import pandas as PD again. There's the thing that's not code, load the data from the provided Excel file. So there's that, and it actually, it knows, let's see, wait a minute, that's not what I want to show. It actually keeps memory of the files you've uploaded, and so sometimes you can just click. You don't have to go to your computer and find it. It's already there. But the point is, I've uploaded this Excel spreadsheet. It's read it in. See this PD read Excel file. The head is the first 5 rows. That's all that is. But it shows you what the statistics look like for just Aruba, Africa, as it goes down alphabetically. So then, it says that there's 66 columns. It gives you the code and whatnot. It tells you it's going to be Bulgaria. I've not done, what you can do, by the way, is your next prompt could be, why does Bulgaria have the highest death rate? I don't know. Does anybody know? I really don't. But the point is, so it isolated that really quickly. And then what country has the highest death rate overall? And again, it would not be a surprise that it's South Sudan, okay, at 26 per 1,000. And what was the worst year, 1988, when it was 74 per 100 per 1,000. And then here's where I said, but why? I knew why, civil war. But so you can, it's sort of, you get three things. You introduce the question in order to generate the code, but you can use natural language to ask other questions because it's GPT 4.0, and then you can get the code, of course. But this, what I like about it is I don't have to cut and paste. This is the copy code button over here. So normally you would copy that code in GPT 4.0 and go over to Google Colab, paste it in, and then this is what you get below. But for some of these more mature programs, you get the visualization right where you are. You don't have to leave the program. It's all there. You can download it, you can modify it, you can do all kinds of things. Excuse me, these are all the accessories to the visualization. But you can see the death rate, thank goodness, is dropped from 16 per 1,000 down much lower over time. So which country had the lowest death rate over time? Qatar. Not too surprising, frankly. It's fairly sheltered. They give the reasons. Uh, and then I shifted gears to NHANES, which is, again, the National Health and Nutrition Evaluation Survey that I really like. I put together a data set. You're welcome to it. I combined all the factors, something like 70 variables. Uh, there's demographics, lab work, physical exam, pretty much everything you can think about, including grip strength, how much sunlight they get, how much activity. So I said, let's just data mine that a little bit. Pretty big file. Again, it read it in. Here it is, PD read CSV. And here's your head again. This could be tail, which would be the last five. That just gives you the ability to look at it real quickly, if you will. And so here it goes further, because let's get back to what I asked it. What has positive correlations with grip strength? Some of y'all out there in primary care land may know that grip strength is not any different than how many push-ups you can do, sit-ups you can do, whatever. But what's interesting is it correlates with both morbidity and mortality. So if you're interested in epidemiology and primary care, grip strength is fairly interesting. What's different about grip strength is it's standardized. We know what a 60-year-old man, what his grip strength should be in the confidence interval, and for women also. So looking at number one is height, and actually age and gender are minus, but they're very positive. You see, it's very strongly negative for females. But here, again, it correlates with forced vital capacity, FEV1, hematocrit, which is interesting. And the point, this is why I really find this data set interesting. When you start looking at what correlates with obvious healthy things like strength, hemoglobin or hematocrit is one and albumin is another. Why? Because as people start to develop chronic diseases and get ill and age, the hematocrit drops, the bone marrow, it just, suppressed, liver is suppressed, albumin drops. So looking at some of these relationships, if you're really on kind of an exploration, if you will, is quite interesting. So here's a plot of age versus grip strength. You can see, so I just said create a scatter plot, and you can see it's kind of interactive. You can mouse over and whatnot. So that's very user friendly. I didn't have to do anything, extra with that. I asked it, how come grip strength has a positive correlation with hematocrit? And I think of all of those, the correct one is overall health. So again, just a little bit more of a discussion. the implications of low grip strength in older adults. It's really what you know. It's as people start to fail, you watch them walk, they're using walkers, you name it. It's all part of the picture, unfortunately. And no, I don't use a walker yet. Uh, so also activity is very interesting, as you can imagine. It's really kind of related to grip strength. These are all factors in the data set. So I'm only showing you a few, but I wanted to kind of whet your curiosity of how many questions you could ask about this. So this was what correlates with activity in this data set. Light activity, so I'd want to look at vitamin D while I'm at it. And then there is vitamin D, B12, you name it. I don't know why household size has anything to do with it. But you can also do a correlation matrix, but actually there's so many numerical variables. This is what you end up. This is not very easy to interpret, but as you know, if it's positively correlated, it'll be reddish. If it's negative correlated, it'll be bluish. So it's just one other way. And by the way, we could have, at the very beginning, if you all remember from an earlier lesson, put in there, please perform exploratory data analysis, EDA. And it would have gone through a lot of these same visualizations. It would have given you descriptive statistics. And obviously you want to look for other things, cleaning the data up, missing data. But exploratory data analysis is sort of a shotgun to get started, to give you that descriptive statistics and visualization. All right, here's another one. They do cognitive scores, but they don't start until age 60. Okay, so there's no point of asking it for everybody. So here's cognitive scores in age over 60. And then I asked, well, what does it correlate with? Probably no surprise to you all. Unfortunately, education, income, strength again, force vital capacity again. To me, what caught my interest, because I had a lot of interest in pulmonology, is you need muscle strength to have a good force vital capacity because you need strong diaphragms and intercostal muscles. So it makes sense to me that the force vital capacity in FEV1 would be similar to grip strength. And in fact, the correlation is very high. So I'm going to stop with that, but just you can imagine, and let's just quickly look at regression. Let's see. Oh, that's logistic regression. Sorry, but that's okay. So we read in the heart disease, the one we played with a lot with 303 subjects, 14 variables. So what I said to it using natural language, not paying any attention to the code, is let's create a classification model using this data set, and there it is above. Impute the missing data with mean or mode. I took the easy way out on that when there are only 3 missing data points. Split the data into train and test, use 5-fold cross-validation. On the test data report, report the AUC precision F1 score and recall. So here's, again, does the head automatically so you can take a peek of what it looks like. Here's the further information. Encode categorical variables. Remember, encode means convert a categorical variable into a numerical. And then, so here's the AUC, high at 0.935, precision high, looks very good if you like. And then you can ask it. What's nice about it, don't forget, you can ask it to explain it. And then after explaining what recall is, which again is sensitivity, it's going to give you all that information. But notice these additional questions at the bottom are kind of interesting. Let's see. But that's probably enough on that. And then I want to show you, we're going to shift gears. Let me look at time. So we got about 10 minutes. So here is a Google sheet. The advantage of this, I think I made this point before, is this kind of forces you, I hope, to look at the data set and look how clean it is. this is unusually clean. That's that heart disease data set. As I said, there's like a thallium missing and a coronary calcium missing, and that's about it. So it's unusually clean. So what you can do is you can start with analyze my data using Gemini. I will editorialize and say I don't think this is as good as Vizly. Uh, and also I want to show you that on my website, the new website, I now have added videos for this, for Gemini, how do you do things, and also for Vizly. So they're short, like 5 minute, 3 to 5 minute videos on doing things like I'm just showing here. So this, again, capturing insights, not a bad way to start. If you got a brand new data set you don't know anything about, it's going over some information, lower maximum heart rate seen in heart disease patients. I think these are talking about treadmill, and they quit earlier due to either chest pain or ST depression, presumably. And so higher values for the number of vessels. This is not a CT of the chest for coronary calcium. This is the old fluoroscopic. I don't know when they stopped doing that. Aaron, do you know? I'm not sure.
I'm not sure, but I mean, we're still doing angiograms, but and CT coronaries at this point, but
Yeah.
not sure when they stop fluoroscopy.
So anyway, so here again, you see some basic charts start to show up. So I didn't really request it. And you'd have to look at this carefully because absence of heart disease over here, presence of heart disease is a different color. And so each one of these, it has both numerical and categorical data here. So let's see what this is. So that's actually just heart disease. Let's get that further. Okay. ST depression, obviously. So zero, in other words, so the people without heart disease had zero. Makes sense. And most of the people that had substantial heart disease had a lot of ST depression. But there's always a false positive and false negative, particularly in heart disease, right, Aaron? I mean, again, it's gotten much better with newer tests, but believe me, it was an educated guess before when somebody showed up, with an MI in the emergency room with maybe a fairly normal EKG.
Yeah,
There's just too many false positives and false negatives.
yeah.
So again, this automatically did this, which was kind of nice. And again, you can copy this. When you preview it, it shows up over here. So you can paste that, create a new notebook and paste it. So I think it did a pretty good job. I give it a pretty good score here for this initial analyze my data, if you will. That is not a bad starting place. Let's see, there's some stuff in the chat. Let me see. Oh, okay. Jason, let's see. Thank you for posting that. Jason asked about AI hallucinations. Not in this scenario. Not in my. What do you think, Aaron? I've not run into any in this scenario.
I have not run into any, but I guess I'm always a little cautious to make sure that whatever result I'm getting is kind of fact checked. But yeah, like I have, because this is all based on the data that you are uploading and that you have provided, and it's kind of analyzing that data set. So far, I have not come across any at this point. But as I said, it would be nice to just be a little cautious.
Okay. And then again, Gemini, to the best of my knowledge, Gemini is embedded if you have a subscription to one of the two, premier Google subscription services like Workspace, and I think there's like Premium One or whatever the other one is. So you get that. How about you all volunteer a prompt? What would you like to see? We're using the same heart disease prediction. How about somebody volunteer a prompt and let's see how Gemini does? Anybody? Be brave.
I have a question.
Okay.
Could we, this is Saba, by the way. Could we see maybe the differences in like, or I guess like the men versus women in terms of like heart disease?
Sure. And actually let me do one that's related to that. Create box plots are kind of nice. Whoops, if I can type, of cholesterol for women and men. And that should show you the difference. And we can do heart disease for sure, but I'm trying to make it a little bit more complicated. Have you all tried some of the others like Julius, or you can use ChatGPT 4.0 with the analysis package? I still think that's subscription. I don't think you can get that free.
I have used Dr. Hoyt, Claude.
Okay.
And Claude,
That-
for coding, Claude is, I find it very useful. It gives like a nice, like it shows its thought process. So I used a lot the Claude paid version.
And Claude, by the way, just came out with 3.7
Yeah.
this week.
Yes.
It required the full 3.7 requires a subscription.
Yeah.
So here is what we talked about. So let's see, I'm looking, there we go. On the right is male, on the left is female. What's interesting is it shows that one really high. So it's not one that you can mouse over, but it was 560 or whatever in a woman, an older woman who had no heart disease, interesting enough. So this is helpful and does it. So would you like to see, Saba, how would you want to rephrase that? What would you like to see? Heart
Maybe,
disease by gender?
yeah, that would be a good one.
Okay.
Thank you.
Notice I said show it. I didn't tell it, I wanted a histogram. I want to see if it should be able to figure it out. So let's see what visualization it comes up with. A bar graph, okay. And that's because it's categorical.
Does the data have HDL and LDL and that sort of thing in it?
No, it's just total cholesterol, this data set. So here it is. And then what's nice about orange does the same thing, but it will give you, this would be a chi-square, and it would tell you if it's statistically significant. If it's numerical, it would give you a t-test. So that's the kind of the cool thing about orange. But I think you can see, looking at females, the dark blue is no heart disease. So obviously heart disease is more common in men. No surprise there with this teal color. But the point is, you can see how easy it was to do that. Any other request of anything to mine from this data set?
Does it have anything like time between detection of a high cholesterol and an MI or something like
No,
that?
this is not
no time
longitudinal at all. Yeah,
It's
this
just
is
a cross-sectional data
Yeah,
set.
all these people had cardiac catheterizations. If they had greater than 50% stenosis, they were labeled as heart disease. Again, an imperfect endpoint, but from the standpoint of education, it works out pretty well. Let's try.
Bob, I had a question. I wonder
Yeah.
if continuous data can be normally in non-normal distribution, and you use, parametric, non-parametric tests. And the description of the data is slightly different with standard deviation versus medians and interquartile range. Does this figure all that out when you presented a data set to say, hey, here's a continuous data set, analyze?
Yeah, it generally does. I mean, we're doing really simple things, but let's try, for instance, what percent of patients with a reversible defect on thallium do not have heart disease. Because again, generally you consider that abnormal, but it isn't 100% by any stretch of the imagination. I want to see if it'll just generate the percentage. But again, this would take you quite a while, probably in an Excel spreadsheet to do this. And this is slower than Vizly, I would say. Yeah, 24%. So Aaron, what's the differential diagnosis of reversible defect in a person without heart disease? Put you on the spot.
Sometimes like if patients do have like vasospasm, sometimes it can present like that. Sometimes, if they have like soft tissue attenuation, usually that presents as a fixed defect. But the only one that I can think of at this point is maybe vasospastic disease.
Right. And then I think that's more common in women, is it?
Yeah. And then if sometimes you can also have like microvascular dysfunction, and then that can also be a reversible defect.
Right. Yeah, well, that was my impression exactly, although I don't have any up-to-date current information, to be honest. That was just sort of what I understood when I actively practiced medicine. It says it's less common in women. I don't know. But
But
there again,
it also says it's 15% of women do not have heart disease compared to 24% overall.
yeah,
So I mean, so that would be like, 9% of men have it. So technically it would make it more common in women.
yeah. So we're at the hour. Any questions though about Gemini? Again, if you have I think Faisal said he had a subscription. Any questions about Gemini? It works reasonably well. I've had it sort of stop and start a couple of times, but again, you can see that the potential is there to get started with the data set, but always remember you must have clean data first. You can do an exploration like this, but don't really create a model or do anything serious until you looked at the data in depth, you've dealt with missing data, outliers, abbreviations, all the stuff you run into with messy medical data. Once all that's done, then it's time to go ahead and do something really interesting like supervised learning. Next week, by the way, we'll be looking at unsupervised learning and also be looking at how do you deal with class imbalance. How do you handle a model if you only have 15% of people with heart disease and 85% that don't? Your output's going to look kind of funny. It does change the model because the model's unfortunately is learning more on the majority class, not the minority class. So those are the two things we'll talk about next week. Any other, oh, by the ways, or questions about Gemini or Vizly?
I just wanted to share something prior to your question. Essentially, this was how, 1 second. This was how, let me see if I can pull it
Do you
up.
need me to stop share?
Yeah, I think that would.
Because I think we have a multiple share. Try it. Supposedly we both can share it.
Oh, okay. Let me try if that's possible. 1 second. All right. So the way like we used to do, or I used to do coding back in the day when there was no large language model, if I had issues with coding, we would have to go to the package website, look at the user guide or API, and kind of figure out what the code is from there by, going through all of this information. So it just goes on to show that. So as Dr. Hoyt was showing about, Vizly and scikit-learn. So this is the actual website of scikit-learn and the user guide for, you know, supervised machine learning models and Bayes and semi-supervised learning. So you would have to go through all of this to kind of figure out what code you're actually going to be using. Whereas right now it's so much more easier by using the integration of large language models in your Python notebook. This is another example of matplotlib to create graphs, where right now just by prompting you are able to get a graph, which is also interactive. But back in the day, you would have to kind of code all of this manually. So I just wanted to show that, we've come so far in a matter of a few years in terms of coding.
Yeah, and that's why I think actually it should encourage people to know a little bit about coding because it's not so frightening.
Right.
In other words, for everybody else, it's like, oh my God, I got to devote a year or two.
Yeah.
Let me just see if it knows how to install, for instance, this new algorithm. I just use that as a more of an esoteric thing. I know that Vizly did it and ran a classification model using it.
Mhm.
So I'm just kind of curious.
Yeah. But yeah, I just wanted to, put it out there.
So it said, no, I can't do it. So, but any other questions? Because I think we'll otherwise wrap it up and plan for next week.
I just want to say thank you, Dr. Hoyt. I just finished a project in a supersonic speed with Orange. So thank you so much. I appreciate
Oh,
that.
good. I'm glad. And again, it is fast and more intuitive, I think. But my last comment will be, I do think we're headed to the point where AI is going to do most data analytics, which is both good and bad, meaning that it's great if it gets to the point where it just does a complete analysis, but still it still could make mistakes, and you have to know what questions to ask it. So I think, like most of AI, it should augment what we're doing, not replace what we're doing. So it should be a good tool in your toolkit. And this is just another example, I think. All right. But if that's all, I wish you all a wonderful weekend and look forward to seeing you next week.
Thank you.
Thank you. See you all next week.
Thank you, Dr. Hoyt.
Take care.
Thank you, sir.
Okay. Bye-bye now.
Thank you.